Hello, how you doing? DeAndre Smith here, and I'm excited to show you this lesson on adding and subtracting fractions. I don't want to take up too much time talking or anything like that, so without further ado, let's go to the board. As you learned from prior lessons, we understand that a fraction is a part of a whole, or a representation of a part of a whole. Well, in this lesson, we're going to take it a step further and learn how to add and subtract them. So to achieve this, we're going to break this lesson down into 4 topics. The first topic is we're going to understand fractions. Second, we're going to reduce them. Thirdly, we're going to add and subtract fractions with the same denominator. And then lastly, we're going to add and subtract fractions that has different denominators. In the example that I have behind me, this is a fraction in its most simplest form. You have the numerator and you have the denominator. Now the numerator tells us how much we have. The denominator tells us how much we have in total. So for example, if we were talking about a pizza and we had 7/8 of it, that means out of this whole box of pizza, of this whole thing of pizza, is cut into 8 slices, and out of the 8 slices we have 7 of them. There are also 2 other ways that you can represent fractions. And these fractions in particular are when you have a whole number and then you have a fraction. So if we look at the example behind me, all of the circles are cut up into 4 pieces. So since we have 2 whole circles circled in, and then we're left with 3/4 as a mixed number, this fraction is written as 2 3/4. Improper fraction form tells us, just like the classic form, it tells us exactly how many pieces that we have, and then it tells us the amount of divisions that it's cut into. So if we count all of the pieces that's cut in, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 in total shaded in, and we have divisions of 4. So therefore our improper fraction would be 11/4. So now let's go into the processes of taking a mixed number and converting it into an improper fraction and vice versa. So what a mixed number is saying is that we have 2 whole things of 4 out of 4. So therefore if we take 2 times 4 we get 8, and if we add to it the remaining 3 we get 11. So let me repeat that. So we're going to take the 2 multiplied by the 4, and then we're going to add the 3. And that gives us 11/4. Now to take the improper fraction and convert it back into a mixed number, we have to utilize division. So we're going to take our denominator, put a division bar, 11. 4 can go into 11 2 times. 4 times 2 is 8. When we subtract, we have 3 remainders. So therefore, our mixed number would be 2 3/4. Let's do 2 more examples. So say for example I have 4 2/5, and I want to convert this into an improper fraction. Well, I'm going to multiply the 4 times 5, which gives me 20, and then add to it the top, which is 2. So I have 22/5. Now to take this improper fraction and turn it into a mixed number, I'm going to take the bottom number, the denominator 3, set up my long division bar, put 13. Now 3 can go into 13 4 times. With the remainder of 1. So therefore, my mixed number would be 4 1/3. Now we're going to start talking about reducing fractions. Now to explain what reducing fractions is, I have an example behind me. So let's first look at the fraction bar with 6/8. It's 6/8 because the bar is cut up into 8 individual pieces, and out of the 8 we have 6 of them shaded in. Well, if we start out with that amount, reducing fractions involves finding the lowest equivalent fraction. So in the bar under it, I have 3/4. So if you look at the quantities as to where they're stopped and how they're divided, 6/8 is the exact same as 3/4. So that's what we're going to get into, the mathematical concepts as to finding equivalent fractions. What we did to find a common factor is that we took out the ones. So what is a 1? Well, a 1 is any number over the same number. So, for example, if I said 2 over 2, that would be an example of 1 because 2 divided by 2 is 1. Another example is 3 over 3. Well, 3 divided by 3 is 1. So therefore, 3 over 3 is a 1. Okay, so what we did was we took 6/8 and we found factors, which was 2 times 3. And with 8, we found factors, which is 2 times 4. Because 2 over 2 is the same as 1, we can take it away. And we're left with 3/4. Now, in order to reduce fractions, we need to first learn about prime factorization. Prime factorization is made up of two words, prime and factorization. So what is a prime number? Well, a prime number is a number that's only divisible by itself in 1. What this means in layman's terms is pretty much, can anything times anything be multiplied to get this? If the answer is no, then it's prime. If it's yes, then it's not prime. For example, 5. 5 is a prime number because can anything times anything give you 5? No, nothing besides 1 times 5. Well, what about 8? Well, 8 is not prime because we can find two numbers that can multiply to give you 8. 2 times 4. Okay, factorization. Factorization is another way of saying something times something. So I know you all are probably sitting there scratching your heads wondering, what does all this have to do with reducing fractions? Hold tight, hear me out. Next couple of clips, you'll see how it all intertwines. So now to find the prime factorization of numbers, we're going to utilize the prime factorization tree. So if we were asked to find the prime factorization of 8, first we're going to start off with two arbitrary numbers that multiply to give you 8. So I chose 4 times 2. So 4 times 2 gives you 8. Well, since 2 is a prime number, we're going to break down 4. 4 can be broken down into 2 times 2. Now I circle all of my prime numbers. So my prime factorization would be all of my circles. So it would be 2 times 2 times 2. If we were to find a prime factorization of 124, well, again, we want to find two arbitrary numbers that multiply to give you 124. So I chose 4 and 31. So since 31 is prime, I'm going to circle it. 4 is not prime, so I'm going to break it down some more. 4 can be broken down into 2 times 2. So therefore, the prime factorization of 124 is 2 times 2 times 31. So now we're going to reduce 24 over 27. This can be done by first finding the prime factorization of 24 and 27. So in finding the prime factorization of 24, we find two arbitrary numbers that multiply to give you 24. So I happen to choose 12 and 2. Now you may be wondering, if I had chose 6 and 4, would it work? Yes, you get the exact same answer. So using 12 and 2, well, 2 is a prime number, so I'm going to circle it. 12 can be broken down into 6 times 2. 2 again is a prime number, so I'm going to circle it. 6 can be broken down into 3 times 2. So therefore, the prime factorization of 24 is 3 times 2 times 2 times 2. With 27, well, I chose the factors of 3 times 9. So since 3 is a prime number, I'm going to circle the 3. And with 9, I'm going to break down 9 to 3 times 3 and circle that. So my prime factorization of 27 is 3 times 3 times 3. Now taking all of that information and piecing it together to the fractions, I can now replace 24 with its prime factorization. And I could also replace 27 with this prime factorization. And then lastly, I'm going to cross out my 1s and multiply what I'm left with. So 2 times 2 times 2 is 8, and 3 times 3 is 9. Let's do another example. So now we are asked to reduce 36 over 22. So first we're going to find the prime factorization of both 36 and 22. Once I found the prime factorization of 36, I end up getting 2 times 2 times 3 times 3. And for 22, I end up getting 2 times 11. So now we can take that information and apply it back to our fraction. So we're going to replace 36 with its prime factorization, which is 2 times 2 times 3 times 3. And we're going to replace 22 with its prime factorization, which is 2 times 11. Now last step is the fun step. Now we're going to get rid of our 1's. Well, we only had 1 in this case, which is 2 over 2. So we get rid of those, multiply our results. So 2 times 3 is 6, and 6 times 3 is 18, and 11 is 11. And there we go. That's our fraction reduced. Now when it comes down to it, in adding and subtracting fractions, we really only care about 2 situations. 1, if the denominator is the same, and 2, if the denominators are different. So what we're going to focus on in the next couple of clips is how to add fractions when the denominators are the same. So behind me I have a fraction bar representing 5/8 and 2/8. And as you can see, since the denominators are the same, all I have to do is add the numerators. So 5/8 plus 2/8 is equal to 7/8. When you have mixed numbers, you simply add the whole numbers and then you add the numerators of the fraction. So we have 1 and 1/4, and then we have 2 and 2/4, so therefore we get 3 and 3/4. In this example, we're going to add 1 and 3/10 to 2 and 7/10. So if we add our whole numbers, we get 3, and if we add our numerators, we get 10 over 10. Well, since 10 over 10 is 1 whole, we can simplify this fraction into being 4. So now in this example, we're going to add 3 over 20 plus 7 over 20. So notice I have 10 over 20 and then I have question marks. The reason I have question marks is because this fraction must be reduced. So how do we reduce the fractions? Again, we're going to use the prime factorization method to solve and reduce this fraction. So first let's find our prime factorization of 10. So I'm choosing the arbitrary factors of 5 times 2. And both 5 and 2 is prime. And for 20, I'm going to use 5 times 4. And 5 is prime, but 4 isn't. So I'm going to break 4 down. So now I had the prime factorization of both my numbers. So now let's piece the fraction back together. Well, in this case, I have 2 1's. So I have 5 over 5, and I have 2 over 2. So what I'm left with on the top is 1, and at the bottom I have 2. So my reduced fraction is 1/2. Now we're going to start to talk about adding and subtracting fractions when they have different denominators. So in the example that I have behind me, I'm adding 2/3 to 3/4. As you can see, the divisions are different. So we can't add them. So what we have to do is find a common number of divisions in order so that we can add them easily. So that involves the extra step. The extra step is called the common denominator. Now if I take 2/3 and 3/4 and now I cut them up into 12s, I now have 7 12s plus 9 12s, which gives 17 12s, which is the same as saying 1 and 5 12s. Now let's look at this mathematically. Now in this example, we're going to add 7/8 plus 8/9. So the first step, we're going to find a common denominator. So we'll set up our 7/8 and our 8/9 vertically. And then we're going to start off by putting a dot fraction bar equals fraction bar. So again, that's dot fraction bar equals fraction bar. The common denominator is found by multiplying the two denominators. So since 9 times 8 is 72, our common denominator is going to be 72. Now we're going to multiply by the 1 that gets us our denominator. So for 8, 8 times 9 gives us 72. So we're going to multiply by the 1, 9 over 9. 7 times 9 is equal to 63. So our equivalent fraction of 7/8 is going to be 63 over 72. And then we're going to repeat this process for the bottom fraction. So 9 times 8 gives us 72. So we're going to multiply the whole fraction by the 1, 8 over 8. And 8 times 8 gives us 64. So now our equivalent fraction for 8/9 is 64 72nds. Now that we have our equivalent fractions with common denominators, we can now add them. 63 plus 64 equals 127. So our answer as an improper fraction is 127 over 72. Now using the conversion techniques, we can convert this improper fraction into a mixed number. If we converted it into a mixed number, our answer would be 1/55 over 72. This fraction is non-simplifiable, so we do not have to apply the prime factorization principle. In this example, we're going to add 1 3/7 to 2 3/14. So to make things easier on us, we're going to first convert these mixed numbers into improper fractions. So if we convert 1 3/7 into an improper fraction, we get 10/7. And 2 3/14 as an improper fraction is 31/14. So now we have to find the common denominator. So again, we're going to put our two numbers on top of each other or vertically and put dot fraction bar equals fraction bar for both of them. So again, that's dot fraction bar equals fraction bar. So now to find our common denominator, we're going to multiply the two denominators. So 7 times 14 is equal to 98. To get to 98, we have to multiply 7 by 14. So therefore, we're going to multiply the whole fraction, 10/7, by the 1, 14 over 14. In our bottom fraction, we multiply 14 by 7 to get 98. So therefore, we're going to multiply by the 1, 7 over 7. Ten times 14 is going to give us 140. And 31 times 7 is going to give us 217. Thus, when we add 140 and 217 together, we're going to get 357 over 98. Now we're going to take our 357 over 98 and reduce the fraction. So we're going to apply our prime factorization, and we get 51 times 7 for our prime factorization of 357. And we get 2 times 7 times 7 for our prime factorization of 98. By getting rid of our 1's, we're left with 51 over 14. If we were to turn that into a mixed number, our final answer will become 3 and 9 over 14. Hello again. I hope you guys were able to benefit from that lesson. As always, if you have any additional questions or if you need any additional examples, feel free to call or email me. Thank you.